Hello guys, today I'm going to do a Cambridge iGCSE Computer Science Paper 1 Theory based on the code 0478/12 May-June 2021 series. It's a 1 hour 45 minutes paper. We have to answer all questions. We have to use a black pen. We have to write the name, center number, candidate number. Okay, candidates. Okay. Total mark is 75. The number of marks are shown in the brackets. Do not use brand names. Got it. So we're going to start with the first question. A denary value can be converted into hexadecimal and binary. So I have to complete the table to show the hexadecimal and 8-bit binary values of the given denary values. Okay. So the first step to do, in fact, is to we're gonna write the 8-bit binary value series like this. So we're gonna just write 1, 2, 4, 8, 16, 32, 64, 128. Okay, so that's like about 1, 2, 3, 4, 5, 6, 7, 8. Okay, remember these values, these are really important. Okay, so based on this, we have a table. So it doesn't matter which way you convert it. This is my way of converting a denary to binary and from binary to hexadecimal. Okay, so you guys can follow any way. The marking scheme is not very fixated, so it's okay. So any method is fine as long as you get the right results. Okay, so we know that 49 is in 49. We can subtract 49 by 32, so it's allowed there. You can go with 49 minus 32, that is 49 minus 32, that's about 17. 16 goes at 17. 0, 0, 1. So we get the binary value for the denary value is about 0, 0, 1, 1, 0, 0, 0, 1. Okay, so this is your 8-bit binary value. Now we have to find out the hexadecimal. Now the hexadecimal way is to split the 4 bits. We have to split them and just write 8421 on top, 8421. So wherever there are ones, you just add the top parts. So we have 1 here, so we add 2 plus 1, that's 3, and we have 1 here, so it's 31 only. Okay, so we just remove these things. You have to just show them in your working, so I'm gonna just write 31 there. Next one is let's see, 123. Okay, 123 can be applicable with 64. So 123 minus 64, that's about 59. It's applicable with 32. Sorry guys about that. So it's about 32 as well. We're going to go with 16. It's about 11. We're going to go with 8 as well, just to find that value out. We're going to go with 2 and 1. So you should be getting about 0, 1, 1, 1, 1, 0, 1, 1. So these are the values for the 8-bit binary digit for the denary number 123. Now we have to find out the hexadecimal value. Same story. So 8421, split the 4-bit binary digits into 4 parts. So you have to remember that 4 bits is equal to 1 hex. Okay, so this is a key factor you have to remember. So we have, this is totaling add ups to 7, this adds up to 11. So we know in the hexadecimal table, this is a table that I ask you to remember, is that denary from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it ends with 15, okay? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. At 9 for hex, the value for the hex value for the denary number 10 is A, B, C, D, E, F. So we can see that 11 should be B. So it's 7B. Hence it's 7B, okay? Now 200. 200 is an interesting value. So the only place where 200 is possible okay, we can go with 128. 200 is possible in 128. So I'm just going to write it down here so it's simpler for you guys to just see the values, how they're going, okay? So, right. Okay, so 200 minus 128, that's about 72. It's applicable with 64 as well, so that's about 1, 0, 0. So we have 8 as the remainder, as the value that we have subtracted. So 8 will go with 8, so that's 1, 0, 0, 0. So we have 1, 1, 0, 0, 1, 0, 0, 0. Okay? So that's one way of doing it. Split them again in 8, 4, 2, 1 because 4 bits are equal to 1 hexadecimal value. So that's 8, 4. So we're going to add them up. It's 12. So 12 should be C. C, 8 should be our answer. Okay? Okay, now we have to answer the next question quickly. So give 2 benefits to users for converting binary values to hexadecimal. Okay? So remember, with hexadecimal, there's a less chance of making an error because it's easier. It takes up less screen. It's better than displaying a lot of binary digits which are made up of a lot of zeros and ones. So basically, hexadecimal helps to simplify it and make the code easier, make the numbers, right? Benefits. It makes it easier to understand. Makes it easier to understand the number. So there's 1 mark. There you get 1 mark for that. And second of all, it looks good. It takes up less space. Okay, that's another. It takes up less space, right? Okay, because it's simplifying. Instead of writing a lot of ones and zeros, okay, on a screen. Okay, so zeros. Okay, so hexadecimal is used to represent hypertext markup language, HTML, color codes, and computer science. Identify 3 other ways that hexadecimal is used in computer science. So we have to ask where hexadecimal is used. Hexadecimal is also used in error codes. These are messages that you get while a web page or web server is not able to reload. So usually an error message will say, it will usually say that the file is not found. So it's usually in error messages. Error messages, that is the number one thing that you should write down. It's also used in MAC addresses. They use a lot of hexadecimal codes. Then it's also used in assembly languages. Okay, so these are 3 things. For 3 marks you need to remember this. Where is hexadecimal used in computer science? Next part. So data storage can be magnetic, solid state, or optical. 6 statements are given about data storage. Tick to show if the statement applies to magnetic, solid state, or optical storage. Some statements may apply to more than one type of storage. Okay, right. So how are we going to do this? Is that no moving parts are used to store data. Okay, this is basically mainly related to remembering data. Okay, you have to remember the information about what is a magnetic, solid state, optical storage mediums. Okay, so in solid states there's usually no moving parts. Pits and lands are used to store data. This is in optical. So this is mainly remembering concept. Okay, so you can just use this to make a mind map or make a table where you can remember the stuff. Data is stored on platters. That's magnetic. Flash memory is used to store data because it's solid state, because there are no moving parts. Parts are rotated to store data. This is both magnetic and optical. So you have disks being with lasers, I think, and magnetic being rolling tapes, right? Data can be stored permanently. You can store data on all types. Magnetic are far the best, I think. And solid states are also good, along with optical storage mediums. Give one example of magnetic storage. Like I said, magnetic tapes. There are one big ways of storing huge amounts of data. Magnetic tapes. Give one example of optical storage. So this is where you can mention DVD. I think you can also mention CD as well if you like, but I'm gonna stick with DVD. Okay, Blu-ray disc is also another option where you can write. Identify which type of storage would be the most suitable for use in a web server and justify your choice. So in a web server, this is where huge amounts of information, huge amounts of data needs to be stored. So I feel that we have to use a, let's say it's 3 marks, and we can say we'll stick with magnetic. Okay, so this is magnetic, so we'll stick with magnetic. Now the justification is, how do we justify this? Okay, so we can say that we need, so like the web server will require a lot of storage, right? So would require a lot of storage, right? So it'll require a lot of storage. So magnetic tapes make it easier to do that. Magnetic tapes make it easier to do so. Okay. The next one is magnetic is also cheaper. Okay, so you can say that magnetic, it is cheaper. That's 2 marks scored already. It's cheaper, and it has there's no requirement for it to be portable, so there are no moving parts. It does not matter. Describe the operation of USB flash memory and how it stores data. So how do we do this, right? So data is flashed onto silicon chips. This is one point where I've seen in the marking scheme that you have to write. So based on, while looking at the marking scheme, I'm saying that we should learn this point, that data is flashed onto silicon chips. Okay, so this is one thing that we can write down. This is really important that you learn this. And the next one, you can say that it uses NAND technology. Okay, it uses NAND technology, right? Okay. The next part is it uses transistors to store data. So that's a third point where you can write it uses transistors to store data. That's another point where you can gain for 3 marks. Okay, great. Logic statements. This is pretty interesting. So we have to draw a logic circuit to represent the given logic statement. Do not attempt to simplify the statement. All logic gates must have a maximum of 2 inputs. Okay, so right, this is, what is this showing? Wow. Okay, this is pretty advanced. So we are given a truth table as well to work with. That's great. I mean, we can work with that. Now we need to understand something, right? There are some errors, right? There are 4 errors in the truth table in the output X column. So what we have to do is we have to find out the values now, okay? So what we're going to do is we're going to just write this in terms of symbol equation. There are 4 brackets, so not A and B. We know that AND is multiplication, so AND B. Okay, or C, that is a plus C, and B, nor B or C. So this is a NOR gate. Okay, I'm not sure what the symbol for NOR is. Let me see. What's the symbol for NOR? A NOR gate, based on the output, should be the symbol, right? Okay, it doesn't matter what the symbol is. Okay, so NOR, just leave it as NOR it is. So B plus C. Okay, so it's NOR. Okay. Got it. And basically NOR is basically the not of B or C, so it makes no difference, so it's okay. You can just put a bar on top, and I'm just going to leave it like that. So work one step by step. Okay, so this is a NOT gate, so AND A should go through a NOT gate. So it's usually a triangle with a small dot circle next to it. Then it's connected with B using an AND gate, right? Actually, you don't need to do the step. It's not. I'm just doing it for my reference. And you connect it with an AND gate, okay? So you connect these both with an AND gate is usually like this. I'm just gonna call this AND gate. Next one, all of this output is connected with an AND gate for a B, for B, okay? It's AND B. So this value, right, that goes through not A and B, so they're connected together with an AND gate, and this is connected. Actually, sorry guys, we have to check out OR C. So the value of this is going through OR C. It's connected there, so it's connected through an OR gate. Keep it like this, and these values are all going to be stored in an AND gate. So we go with an AND gate, we go with B as well, because we're saying AND B, right? We're connecting this value, we're going with AND B, so we're just going to rub off this location. We're going with AND B, right? Okay, right, so we're going to connect all of these tubes to, I'm not sure, we actually just rub that off. So we're connecting both of this with B, because they're saying AND B. So we have to connect both of these with an AND gate. So we're connecting the value of all of this, of not A and B or C, with AND of B, okay? I'm sure you get this, okay? B or C. Now this is the important factor where we go with B again, create a circle there, B or C. So we go, both of them will go through an OR gate. And remember, these values, right, are all connected. They are all connected with a NOR gate. So we have to go with a NOT of C, right? NOR C, so B or C, everything that is not B or C. And they all should go with a NOR gate. This is the symbol for NOR operator. I think that's it. The logic gates look pretty good, pretty okay. No errors made, okay. Next portion. We have to check the error at the truth table. Okay, this is where we have to do the calculation part. We have to do the calculation part of this. Okay, how are we going to do that? Is by checking out the equation itself. We know that the equation is x is equal to brackets not A and B or C. Sorry guys if I'm doing this as fast as I can to do this video. Okay, so we have B or C. So based on this, we have to understand how to do this of the logic gate, right? So we have to look at the logic circuit and understand what it says. So it's saying not A, right? So when it says not A, it's something A not. Something that is not of A. So let's just look at that and say that this is 1, 1, 1, 1, 0, 0, 0, 0, and then it's not A and B. Okay, so we have not A and B, so we have to multiply them. So 0, 0, 1, 1, 0, 0, 0, and 0. Then once we're done with that, we have to find both those values and store them with OR C, right? So we have to connect both of them with a plus, right? We have to connect these values that are given with C. So I'm just going to call this value Z, okay? All this value, the total of all of that, or C. So we add them, we get 0, we get 1, we get 1, we get 1, 0, we get 1, 0, and 1, okay? So we add them up. After that, we have to do AND B. So all of these values that are stored here, we have to go with AND B. These values, the Z values, we're going with Z and B. We multiply all these values with B again. So 0, 0, 1, 1, 0, 0, 0, 1. After that, we have NOR B or C. So now what does this NOR B or C mean? So this NOR B or C, it tells us that something that is something that goes through this is a NOR gate. Okay, I'm just going to show you how a NOR gate goes with basic gates. So it's just it's basically an OR gate, okay, combined with a NOT gate. So we can look at this and understand that it goes, that these values that are going through AND, okay, this value, I'm just going to call this as Y. It's going to be Y, okay, Y, and it's going to be Y, it's going to be Y or or the value that is b plus c. So we have to find out what is b plus c. B plus c is 0, 1, 1, 1, 0, 1, 1, 1. Okay, we have to do y plus b plus c, right? So it's going to be y plus b plus c. So that is about 0, 1, 1, 1, 0, 1, 1, 1. And we have to do everything that is not y plus b of c. That's 1, 0, 0, 0, 1, 0, 0, 0, which technically shows us what the NAND gate is about. Okay, so we have everything that's going through, and with the opposite addition, both of these values that are added together. So the error, right? We can see that there's an error in row 2. We can see that there's an error in row 3. This is correct, this is correct, correct, correct. Then there's an error in row 7, and there's an error in row 8. So there you go. These are the basic gates that help us to simplify and help us to find out where the errors are. Okay, so as you can see, row 2 has an error, which is 0, and row 3 has an error, which is 0. And row 7 has an error, it's 0, and row 8. It should be 1, and this should be 1 as well. So we can finally write that it is row 2, row 3, sorry, actually you don't need to write row 2, I mean you just write the numbers row 2, row 3, row 7, row 8. So this is how we find out the value based on basic gates. Okay, always do it simplified. Make it simplified so it's easy for you to understand how this goes, okay? Alright. Okay, next part, captures all data. Okay, so 3 types of internal security risks: virus, spyware, and denial of service attacks. Tick to show which statement applies to virus. Spyware captures all data. Now this is, again, you have to remember the data. So we're going to use spyware for capturing all the data using a keyboard. Virus is possible to be installed in a web server. Denial of service prevents access to website. Malicious code is always virus and both spyware. Self-replicating, only virus replicates itself, and virus also damages the files. Name 3 other types of internet security risks. There are 3 types, which is known as phishing, farming, and hacking. These are the things that you need to remember and learn, okay? So phishing, farming, and hacking as well. Next part, I'm just going to do it again. Yeah, there you go. State 3 ways that data could be accidentally, you could either, like, it could happen through fires, and it could happen through humans, like through human error, that's such as accidentally deleting a file, right? Accidentally deleting a file. And it could be maybe a software error. Software error. This is 3 marks. There you go. We're going to quickly move on. So this is microprocessors. The question: microprocessors, remember to always remember the same format. This is really important. So identify 2 types of sensors that can be used in a security light system. They specifically ask security light system. This is with light, and you have to write motion as well. Why? Because it's saying and when movement is detected. So when light only comes on when it is dark. So they're mentioning light sensor, and when movement is detected is mentioning of a motion sensor. Describe how the sensors and microprocessors control the security light systems. This is 8 marker. Okay, it's pretty 8 markers. Usually this comes up with 6 markers, but we're gonna keep it as 8 markers. Okay, so sensors, remember the marking scheme. Okay, always, guys, always refer to the marking scheme because it teaches you how to answer these type of questions. These sensors, they send data to the microprocessors. Okay, send data to the microprocessors. Okay, this is I'm referring this from the marking schemes. Now the data converted to digital, because it's analog, we convert the analog the analog to digital we use by using a ADC, okay, analog to digital converter, okay. Then the microprocessor, it checks out these values, right? The microprocessor checks the values, checks the values, the new data, to the, it compares it, basically. It compares it, we can add the checks and compares the value to the stored data, okay. Next one, if no values, right, if the values are within range, if values are within range, action not taken. If both values, so if values are within range, action not taken, right, no action, actually no, action is taken, so right, action is taken if values, because values, if they are within range, action is taken, and if not, right, and if not, sends signal to switch light on, okay. Sorry for the handwriting. So then there's a timer that is set. Remember, there's a 1 minute before switching off, so there's a 1 minute timer, set, and there's an actuator. These are usually movement devices. Actuator used to switch on and off the light. This is all theory part, and we can write about 1, 2. So we need one more point, and you just need to write, we can say when timer reaches 1 minute, the microprocessor sends signal to switch light off. And remember, repeat the process. Whole process is continuous. It'll keep running. Whole process is continuous. So write these 8 points down for 8 marks. There you go. You score the marks. Now, cookies, right? A cookie could be automatically enter user payments details when the user makes a purchase online. Describe how cookies can be used to store and automatically update. Enter users payment details. So how this works is the web server sends a cookie file to the browser, right? To the browser, and what this does is the cookie file stored by the browser's HSD, which is stored by HDD, and when users payment details are stored in an encrypted text file. Okay. Explain why a user may be concerned about their personal data and browsing habits being stored in cookies. Right, privacy issues, maybe because there are privacy issues affected. That's 4 marks. So we have to describe why. 4 from the 4 points. It's privacy and personal reasons. That could be 1. Personal reasons. Then profiling the user that can exploit their identity. Then there could be some crucial information about the user, which is crucial information stored that could be dangerous while intercepted. Could be dangerous, and the computer is maybe prone to hacking, maybe, if it's prone to hacking, which can exploit, again, user identity. And information. Okay, next part. Julian uses HTML to create a website. Give one example of HTML structure. Mainly it's line breaks. I think the other ones give two examples of HTML presentations. Example of HTML font color is one. You can say font color, and you can also say font style. Explain why Jolene separates HTML into structure and presentations. Easy to change. That could be easy to change, as well as easy to add new content. Easy to add new content. These are 2 points that you can write. Complete the paragraph and that describes one method of operation for a keyboard using the most appropriate terms from the given list. Not all terms on the list need to be used. Okay. A keyboard has key matrix underneath the keys. When a key is pressed, it presses a. Okay. What's the most common? I think a switch, right? Switch that completes a circuit. Most probably, it completes a circuit, and this allows the current, because without switching on the circuit, the current can't flow, right? So the current to flow, anything that flows is a current. Okay, and the location of the key pressed is always calculated where it's located, right? And the location of the keys pressed is compared to the character map. Maybe I think the character map. I think that's the most reasonable answer. Character map to find the binary value for the digit. Okay, binary value for the key that is being pressed. Oh wow, actually this paper is pretty short, so there seems to be no questions. Okay guys, with no questions here, we are going to end the video here. So if you like the video, please like, share, and subscribe. So hopefully I should be doing a new paper, and let's see about it. Okay.